Hey, it's Plumber Tom. Thank you for watching my videos. I wanted to let you know really quickly about some awesome resources that I have for you as you're trying to learn. I have free practice tests that you can take if you're preparing for a state test. I have preparation courses that you can take that will guide you through that process if you're getting ready for a test. I have other courses that can help you in learning the plumbing trade. So make sure to check out those resources. You can find a link in the comments below. When you participate in those courses, you're helping me to be able to create more content. So I really appreciate your support. Thanks for watching. Now, these tank type natural gas water heaters or propane water heaters are probably the most common water heaters installed in the United States. They are still most commonly installed in new construction today, although tankless is gaining some ground. But in order for you to be a successful plumber, you should have a thorough understanding of a gas-fired tank-type water heater, the parts that go into that, the components that make it work and how they work, so that as you're out there working with them, installing them, troubleshooting, repairing, you can be knowledgeable as to what these are all about. Now, as you can imagine, the development of these tank-type gas-fired water heaters has been an ongoing experiment over time. And they continue to change. Government regulations require manufacturers to modify their design regularly. But let's go back and just start with the very most basic concept, okay? That is, you have a tank, you put water in it, and you want it to be hot. So what do? Well, early design says let's just put a fire under the tank, and that will heat the water. But if you put a fire under it, then it needs to have a chimney or a flue, somewhere that the exhaust from the fire can go. So we take the tank, we hollow out a chamber in the middle where the gases can flow up and out. Now we can heat from underneath. Well, in order to have a fire underneath this tank, you're going to need to have some kind of a gas burner. So they put a plate underneath there that disperses the gas and distributes that flame underneath the tank to try and heat it a little more evenly. Already we face the challenge that we're heating a cylinder of water from the bottom, and creating even heat is going to be a little difficult. But at least let's distribute that out a little ways. Then we have to consider the necessity of control for the burner of that plate. We don't want it burning all the time, or that water is going to overheat. So we need something that can turn on and off as needed to be able to turn on that burner and turn it off when it's not needed. And so we have a gas valve. This gas valve is a control that is connected to a thermostat. That thermostat reaches into the water heater, senses the temperature of the water inside the tank, and indicates whether it needs to fire or not. When it needs to fire, it lets the gas in, it heats the water. When it's warm enough, it turns off. But then we have the question of how are you going to light that fire if it's turning on and off the gas regularly? So to solve that problem, they created the pilot light, which is basically a standing flame that's always on. A little fire that's ready to ignite the whole burner when the rest of the gas comes through to heat the water heater. More modern water heaters are getting rid of the pilot light because a standing pilot that is constantly burning natural gas is not as efficient as being able to ignite it, say, with an electric ignition, a spark, that could be turned on and off. And then we save gas. So that's the direction that we're going with it today. But back in the earlier days of this, we just had a standing pilot light and it burns all the time. A lot of water heaters are still that way. But then we run into this scenario. What happens if the pilot light gets blown out or goes out for some other reason? And the water heater senses that the water has cooled off, and the gas valve opens up and allows gas into the burn chamber because it's time to heat, but there's no pilot light to ignite the gas. It's going to open up and just let gas flow and flow and flow. It will overflow the burn chamber. It will come out the top of the flue. It will fill the house with natural gas, which is highly explosive. And you can blow up the entire building. It could happen. So we need some other safety involved here that would say, if the pilot's not on, let's not let any more gas come through, or else we'll blow up the house. And so they developed the thermocouple. The thermocouple is a small copper wire with a sensor at the end that will sense the pilot flame. That pilot flame will send an electric signal by heat back to the gas valve that says, yes, there is a pilot, so yes, you can let gas through and it will burn safely. If the pilot goes out, then the thermocouple will indicate to the gas valve, no, there's not a pilot here. There's no way to ignite the gas if you let it out, so don't let it out. This is a really basic, I don't know, maybe it's a little more complex than basic, but it is a mechanical system. There is no electronics involved with the early gas valves. It just uses heat, it detects heat, and it opens and closes mechanically. As people have used tank-type gas-fired water heaters in their homes over time, it became evident that there is another risk, a real danger for explosion, and further safety devices were implemented to stop this issue. Here's what it is. Even though on the side of a tank-type water heater and most gas-fired appliances, there are stickers, signs, and things that indicate you should not be storing flammables next to this flame-fired appliance, humans ignore or are unaware of the risk, and they find the mechanical room as a wonderful space for storing things, including flammable liquids like paint thinner, gasoline, and whatever else. I'll never forget the time I went to service a water heater in an apartment building up by Utah State University. And these students knew that they were going to be moving sometime in the future and decided that they would hoard cardboard boxes for the purpose of packing later. And where did they stick them? In the very tight water heater closet, floor to ceiling, totally packed in was this cardboard box collection. I mean, it didn't burn the place down, but really not the best place to store those kinds of combustibles. This may also be in the garage, right, where there's going to be possibility of gasoline fumes. So, the danger here is that as the water heater is drawing air into the burn chamber, it can also draw in flammable vapors if they are loose and escaping and in the air around. It will draw those in, and then they ignite. And it can ignite a big amount of flammable vapors, causing a house fire. So, to protect people from their stupid selves, the government said, let's put a safety device on this that will turn off the water heater if there is any sort of a flash burn from a flammable vapor being brought in. So at first they just put this in line on the thermocouple. It's an additional sensor that would cut the signal from the thermocouple, shutting off the gas valve if there's a flash burn inside of the water heater. Newer electronic valves that we'll talk about in a minute use an external sensor. It's going to just feel from the outside of the burn chamber and detect if there is a flash burn inside of there. It will close off the electric circuit that runs the gas valve and shut it down. Either way, water heaters are now required to have some safety to protect people against blowing themselves up from storing flammables by the water heater. But that brings us to a discussion of the burn chamber itself. Earlier on, the burn chamber was, for the most part, open to the atmosphere around it, meaning you could just take off a metal panel or slide a door open and have direct access to the burn chamber. Now, government regulations require that that burn chamber is sealed. So even the access to the front, if you need to make repairs or you're trying to get into the fire chamber underneath the tank, you're going to have to take off a panel that has been bolted to the front and fire sealed. This way those flammable vapors can't come out. And if there's a flash burn, it burns inside the chamber, puts it all out, and it stops from the spread of that fire outside of the water heater. And that brings us to an examination of the more modern gas valves. Particularly Honeywell is a brand that came out with a gas valve that is not mechanical, it is electrical. It has a small millivolt electrical circuit built into it. A circuit board, a computer, the whole works. Now, how does that function if it's not directly connected into an outlet receiving power from the wall? Well, you remember we have a standing pilot. That means a flame that's always burning to ignite the burner. The thermocouple senses that flame and tells the gas valve whether it can burn or not. Engineers decided if we have this constant burning energy source, why not try to harness some of the heat or energy from the flame and use that to power our electric circuit? And so they did. They came up with what is called the thermal pile. It functions very much like the thermocouple in that it is inserted directly into the pilot flame and senses the flame, but not only that, it draws from the heat of that flame a small amount of electricity that it runs up to the gas valve, and the gas valve once again is operated by an actual electrical circuit. This Honeywell valve also senses the water differently. Previous thermostats in the tank type water heater would sense the water using a metal thermostat. Now they put a well into the water, so it still penetrates the tank water to sense temperature, but it's just a plastic well. That means this well provides an inlet for an electric temperature sensor, which wouldn't do so well if it was in water, but if it penetrates into the well, it's surrounded by the temperature of the water without ever touching the water. The nice thing about this is that that thermostat, the electronic one, doesn't wear out over time. The older thermostats that were metal, they probed into the water, they would build up scale, they would become less accurate in their ability to detect the temperature of the water, and over time they became less efficient, and you would have these roller coaster ride temperature differences. It would cool off too far, it would overheat. The sensor was not as accurate. Now with an electronic sensor in a well that never touches the water, it will never corrode. And in fact, these Honeywell gas valves are able to detect temperature a lot more sensitively, so they can dial in that temperature of the water within a few degrees. What this means is, rather than letting it drop 5 degrees and then heating up again, it'll drop 1 to 2 degrees and heat, and we maintain a much closer set temperature than when we're dealing with the old mechanical gas valves. One other important note with the Honeywell type gas valves that use a thermal pile to sense the flame and to create an electric circuit, they have wired into that thermal pile circuit the safety that will shut off the water heater if there's a flash burn. Again, going back to flammable vapors or overheating inside of the burn chamber. When that happens, there's a sensor on the outside of the burn chamber that's wired right into the circuit sensing the pilot flame, and if there's a problem, it will electronically shut down. It will tell that circuit this is not safe. And similar to the thermocouple shutting off the gas valve when there's not a pilot flame, it will shut off the gas valve when it senses either there's not a flame or that there has been too much heat, an overburn inside of the burn chamber. Some of the other added benefits of this electric circuit built into the gas valve is that it can do self-diagnostics. You'll find on there a number of flashes and a little LED lights. Those flashes can indicate whether it's working properly, whether it has an issue, and in a lot of cases, what those issues are. This really helps us with troubleshooting and repairs of this type of gas valve. In recent years, as of I think it was 2019 or 2020, Utah specifically required a different type of tank burner. It's called a low-NOx. Now, there are energy efficient appliances that use energy better and apply more of the heat to the purpose. Say like heating water, we use more of the energy and it gets us more hot water. Low-NOx is not talking about energy efficiency. NOx is short for a nitrous oxide, is referring to a gas that results from combustion that goes into the air, a greenhouse gas, supposedly destroying the atmosphere of the world and causing global warming and all of those things. I'm not going to get into the political mess of true or false or whatever all that is. Let me just state that low NOx means that the burner creates less nitrous oxide in the exhaust coming from the water heater. So basically, it should be better for the environment. And for that reason, Utah said, we're going to require these for everyone. And now that's the only type of tank water heater that you can buy here in Utah that is, gas fired. It has to be the low NOx. Well, that's a good thing. Let's say that we are saving the environment. The disadvantage to these is that we lose the sealed burn chamber. If you look on the front of any of these gas low NOx tank type water heaters, it actually injects the gas from the tube coming down from the gas valve into a wide open hole. It's about 2 inches in diameter. And that gas just shoots into this rectangle shaped burner, which burns and distributes the heat a little differently than the round flame burners that we used to have, and maintains a better exhaust for the atmosphere. But the design itself is not as safe, frankly. Once again, when it comes to the burning of flammable gases someone stored around there, we just took away the safety of a sealed combustion chamber. So it's kind of a step backwards as far as those safety measures. But it's what we're required to install in Utah for now. And so, well, that's what we do. As we consider the basic function of these water heaters, the tank brings cold water in generally from the top, diverts it down to the bottom through what is called a dip tube. It's just a pipe that runs inside the tank and pushes the cold water right down to the burner and right to the thermostat where it can be sensed. This way, as water flows out of the water heater and hot water is going to fixtures, cold water is being drawn in and it puts it right where it needs to be heated. Now, in general, hot water rises to the top just like hot air rises. So the hottest part of the water is going to sit at the top of the tank, and the cooler water will settle to the bottom where it can then be heated. But we help that by just pushing it to the bottom to begin with. Without the dip tube, without forcing cold water to the bottom, water always takes the shortest path. And it would just go straight from the cold side out the hot side. And if the dip tube is bad, if it's not pushing water to the bottom, people will complain that they just never get hot water. It's always kind of lukewarm. And they may have it cranked all the way to the hottest setting on the gas valve and still only be getting lukewarm water. This is because they're drawing cold water through as they're getting hot water out. Water heaters also have an internal protection against the corrosion that naturally happens with hot water and sediment and mineral in the water. It's generally going to eat away metals, so they put what's called an anode rod inside of there, a sacrificial anode rod. It's being sacrificed rather than allowing the water to eat the tank. Those minerals collect on and eat the metal of that anode rod. So most all of the tank type water heaters are going to have a rod inside of them. As we go forward into the future with gas-fired tank-type water heaters, what might we expect? Well, a continued push for energy efficiency, and that would include the removal of the pilot light altogether. The pilot light is still installed in the low NOx water heaters that we've talked about, as well as any of the others with the thermal pile or the thermocouple. But getting rid of that standing pilot would save a lot of gas. So what we would be looking at is a gas water heater that uses an electric ignition. You'd have to plug it into a wall. And in the future, it's possible that we'd have to get electricians in there to create an outlet so that we can plug in the water heater. It's the only way we can get rid of the pilot and still be able to ignite the gas as needed. That's how furnaces work today. Most furnaces do not have a standing pilot, but use an electric ignition. You can hear it click, 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 burn. That's how water heaters may work in the future. Already in the past, we've seen an increase in insulation. In 2015, the insulation went from a 1-inch to a 2-inch all the way around the tank. That made them bigger and more challenging to install Could that still happen again? May they require more insulation? Who knows? This concludes our discussion of the gas-fired tank type water heaters. Hopefully this discussion helps you to understand the components that go into this, the different functions that they have. So as you're looking at these, as they're having trouble, you might be able to troubleshoot. Overall, it's important to understand the way that these things work, the safeties that are involved, so that as we install these, we can make sure that they're installed properly. And also, if they have trouble, we'll know about what to do to get them fixed. I'll see you in the next one.